Okay, turn on the mic might help. How does this sound? Maybe yes.
Okay, turn on the mic might help.
There we go. Okay, now you can mute. So I don't get the echo. All right, well that was a lot of fun. Man, I've got to set myself up with the UPS for that. Power was out for like what? 3 seconds, something like that. But it was enough to take my computer down. It reset the routers. Those took forever to come back up. Yeah, that was not fun. So let's go ahead and I guess the answer here is that playing with unsafe Rust is not safe for your power. However, we have Sylvie can hang out with us a little bit. So one of the things that I did, no, you don't want to hang out? Oh, okay. Never mind, he won't hang out. Ooh, Codel, yeah, that's good. Sure, I agree with that. Let's open, exploring. Okay, so I want to reconnect back to you again. I know, stream's back. Yeah, I saw at Costco the other week. I saw a UPS for like $100 or $200 each one. It might have been $200. I can't remember. And I was like, I wonder if I should get one. And then I was thinking about that. I was like, nah, it's like power hasn't gone out here in like when I've been streaming for like this stream for like, I don't know, it went out once. And then it's like, it's probably going to be fine for like, you know, I've been streaming for years here at this location. It will be fine. I don't need to spend that much money on this. And now since then, I've had power turn off and turn back on like really quickly twice. And this time during a stream, which is not optimal. So I think I'm gonna have to go back to Costco and get one of those. So fun. Let's see. Now, the nice thing about using a code space like this is that's all on a different server. All my code is here, so I didn't lose anything at all, which is another reason to do something like this. But okay, so as a sort of like a recap of where we were, we figured out how to use unsafe cell in order to get mute, so we can then mutate this kind of stuff. Now, I don't think I need anything crazy. So let's go back into the documentation and sort of play around with and take a look at that again. Okay, so if you create a safe reference with a lifetime A, either a reference to T or a mutable reference to T reference that is accessible by safe code, for example, because you returned it, then you must not access the data in any way that contradicts that reference for the remainder of the lifetime of A. For example, this means that if you take the mutable to demutable reference of T from an unsafe cell and cast it to a reference to T, then the data in T must remain immutable. So modulo any unsafe cell data within T, of course, until that reference's lifetime expires. And oh, okay, that's read as mutable pointer. Okay, so a mutable pointer of T. All right, so if we have a mutable pointer to T, then we need to follow all those or star mute. Okay, star mute. We could use star mute. That sounds cool. Now, I'm curious because like I don't think I can do this wrong, right? Like here's this here we have this get mute. I don't think that I can like now do this in sort of like the bad thing to it. It's like, can I say unwrapped immutable location dot x plus equals to 1.0? I don't think I can do this. So I can't actually like change things. And I don't think I can just say like, hey, I want you to be a mutable reference to this. Yeah, so like that's gonna be that. Can I just say mute? No. Now can I just say that you are mute here and do that? And if that's the case, what's the difference between our data to get and the data to get mute then? So if I do this and if you work, so we would expect this to now be 12. And you are. What's the difference between get and get mute? Now I'm still getting a mutable reference to this. So once I get that out, I can't, I guess like I could do stuff to it. At all times, you must avoid data races. If multiple threads have access to the same unsafe cell, then any writes must have a proper happens before relation to all their excesses, or use atomics. To assist with proper design, the following scenarios are explicitly declared legal for single-threaded code. So a reference to T, so a T reference can be released to safe code, and there it can coexist with other reference T's, but not with a mute T. So here we see that here. We're getting, well, hold on, let's put this back to what we have here. So we're getting a reference to our type, and it's sort of interacting here. But now it's like, it's been released outside of the unsafe block, so now it must follow all the rules of everything else, and the compiler is going to check it for me and just make sure I don't get into trouble. Lord Mist, hello! A mutable reference to T reference may be released to safe code provided neither one... Okay, so basically, same exact thing. I have to like make sure I don't also have... Now, okay, so look at this. We have this wrapped location, get, mute, and then get. So if I try to do this down here, are you gonna yell at me? Yes, now you yell at me because I'm doing this with both a mutable reference to T and an immutable reference to T. This is completely and totally illegal. I can't do that in any way whatsoever. Oh no, I'm doing unsafe. We're doing a deep dive into Rust standard library, and we're in unsafe cell. So at this point in time, when I get the immutable reference, it's basically internally saying this is no longer safe to use. I can no longer use this again. It's not borrowed, but it is essentially checked for me. I can't use it. Note that whilst mutating the contents of an unsafe cell, even while other unsafe cell references alias the cell is okay, provided you enforce the above invariance some other way. It is still undefined behavior to have multiple mutable references to unsafe cell. That is, unsafe cell is a wrapper designed to have a special interaction with shared accesses. There's no magic whatsoever when dealing with exclusive accesses. Neither the cell nor the unwrapped cell may be aliased for the duration of that mute borrow. This is showcased by the get mute accessor, which is a safe getter that yields a mutable reference to T. So this is a safe getter, whereas this is also a safe getter for like just immutable access. That being said, I can still do cool, crazy, fun stuff. So let's rename these. We're gonna call this safe get. So here, this and this become safe. Now let's try another one, and we're gonna do slightly less safe. So we're gonna do a unsafe function, just sort of like, I don't know if it really is unsafe get, but we're gonna find out. So unsafe get, I want a reference to self, and we're gonna do this star T. And so we're gonna just do a self.data.get like that, and return what it gives us. You are expected muter use star mute T. Oh, so it is a mutable reference. It's a mutable star T, even when I'm just doing the get here. So it's already sort of going to let us know. The type is star const T, but it does allow me to do this, which is interesting. Here, let's try this. Can I do const? That also works. Okay, so both mute and const works here. Then let's just take those out and try just some. Well, of course it does, but star const T is an immutable raw pointer. True, right? So I can't change it. And I don't want to change the pointer, I just want to change the stuff that it's pointing to. So can I create two things? Let's do some unsafe things here. So unsafe, let's grab the first, so it's gonna be our wrapped location dot unsafe get. We get that. Let's get it again. So let second equals wrapped location dot unsafe get. So far, it's not yelling at me for having access to that twice. Now let's mutate the first one. Since both are unsafe to deref, it doesn't really make a difference, right? Yeah, it's probably gonna yell at me soon. Because unsafe doesn't mean that I can just do whatever I want and all the rules of the borrow checker and everything else go out the window. Unsafe just is like is just a warning to say like, hey, some of the safety checks are not going to be running anymore. Okay, so if I try to now get like our mutable access to this one, which I think we need a mute here. Now I want to be able to say, first I want to get you as a mutable reference to first. It just allows you to do more. Yeah, exactly. Mismatch type. Oh no, I don't want to return you. I guess let's do that unwrapped mutable first equals. I think it's gonna be this mute and then dereferenced first. Yeah, there we go. Okay, that gives us a mutable location. Now you Okay, cannot borrow first as mutable. It's behind a const pointer, a star const pointer. So change this from a star const pointer to a star mute pointer. And I'm allowed to do this. So the we can return a star const t or a star mute t here. The const is an immutable pointer, means we cannot get a mutable reference to the data. Well, I mean, can you get a mutable reference since it's a raw pointer? I mean, it doesn't let me unless that's Rust Analyzer yelling at me. Just using X as, ooh. Just using X end. I didn't realize that. Okay, hold on. Let's put this back as a const. Is that really not an error? Is that just Clippy yelling at me? So if I do this, and I now try to change this, so we then say unwrapped first dot x plus equals to 10.0. Okay, so we do mute first as mute. So it's gonna be mute, not whatever that was. First as mute. Wait, mute star. Wait, that doesn't go here, right? It goes up here. Line 47. Oh, here. Oh, okay. Hold on. So we're gonna do unwrap mutable first. So let's reset there. First as mute. Sorry, I'm following like both of you, and I think I'm like going back and forth between both of your suggestions at the same time, which is not the best. Luckily, I've got the I'm able to like see the what you're saying like quickly. So this is gonna be our mute dereference first as mute. So you're suggesting star? Oh, get rid of that mute. This one. So first as mute. That. Okay, so I get that out. Now you can't tell me what you are anymore, which means I have to tell you what you are. Or I have to say that you're a type, so you're a location. Location. Oh, and the star at the front. Okay, we're back to here. So you have a star mute location. Now I need to dereference this to get access to it. There we go, and that works. Now we can then take a look at the second again. So I think I can do a debug on a dereferenced second. I don't want to, oh, and then I want to borrow you because of debug. So if I do that and we run you, then we're able to see that we did mutate it multiple times. Okay. We got a immutable and mutable copy out of it twice. Okay. Yeah, so what I have up here is incorrect. It can be either of those things, but we can still get this const t out of here. It's just gonna yell at me. What were you thinking, KJH? This is Lord Mist, I think. Lord Mist wanted the code to actually be safe, and he wanted the code to not be correct but still work. Unnecessary parentheses, huh? Really? So I can just do that? Yeah, I guess so. So we can just do this. You don't need to be mutable because you're just a pointer to a place in memory, essentially. And we have another pointer to a place in memory. Then we're sort of like doing mutable stuff here. Now, what happens if I try to do this again before I do this unwrapped mutable first? Let's say I try to do this again for a second here. So let's do let unwrapped mutable second is going to be equal to second as mute location. Now I have this out here. Let's like, we'll do the first one first and then we'll do it again here. So we'll do star unwrapped mutable second dot y plus equals to like 100. And again, this works. It just allows me to do that. Now it's technically going to be fine, but it's I now have like two mutable references to the same area in memory, which is like, that's a big no-no in Rust borrow checker. But I'm kind of like in an unsafe block, so that kind of stuff I'm allowed to do here. Yeah, in this case, it's safe because they're star mute and not reference to mute. Right. But it's still up to me to make sure that I don't do something really crazy in between doing this here and doing something with this. I don't like, what could I possibly do to it? I would probably have to be something else. I have not looked at pointer read yet. No, not quite yet. We can add it to the queue. Let's add it to the queue. So here we are. You. So we have at, what is it? Pointer read. There. Okay, so it is saying about the reference, like the reference as a point to the pointer. Okay, examples. Here's an example showcasing how to soundly mutate the contents of an unsafe cell despite there being multiple references aliasing the cell. So we have this unsafe cell that holds an I32. We get that into there. We get 2 pointers from that unsafe cell. Now, I guess in this case, we're getting two references to unsafe cell in here. So then we do an unsafe block. Okay, so then we get our P1. We do a get on it, which is essentially a borrow, which becomes this mutable reference to an I32. And then P1 exclusive. Okay, then we can just add to it. But we can't, this P1 can't go beyond this point. So unsafe. Within this scope, nobody expects to have exclusive access to X's content, so we can have multiple shared accesses concurrently, which is, I think, what we did. So P2 shared. Okay, so it's going to be this P2. We get that out once. We then assert it's equal, so we get that. And then we get P1 out, and we assert that they're equal when we do that. Okay, that's like similar to what we did. The following example showcases the fact that exclusive access to an unsafe cell implies exclusive access to its T. With exclusive access, unsafe cell is a transparent no-op wrapper, so no need for unsafe here. Oh, really? So we get, okay, so we have throw our stuff into our X, which is the unsafe cell. I want to get a mutable reference to this unsafe cell. Then I can dereference and get mute. So that I guess like the star to get it gets me that thing because it's I'm just doing the get mute directly on here and the dereference all at the same time. When we own the value, we can extract the contents for free. So X is this unsafe cell, and we could do into inner on it. Then just grab the stuff out. Okay, that's, I mean, it seems pretty cool so far. Let's take a look at some of these implementations. And let's also grab our code out. Okay. Okay, so this is going to be, we have new. So this basically is a constructor. So constructs the unsafe cell instance, takes in any type, and stores it away. Now, is the type, I don't see that type being constrained in any way. No, here it is. It's sized. But is that, the question mark means that it's not necessary. That means it's optional, right? I forget what the question mark is in that. Oh, this is, so over here, this is called Notion. I'm using Notion for this. Yeah, it's interesting that it's that they're constraining by that. So let's add this in here. So the type T is optionally constrained by a sized. Do I have the size trait? I do. Marker sized. So that's, I guess that feels interesting to me. All generics come with the T size bound by default, so you can use, oh, it's using the optional size to opt out of that. Oh, okay, I did not realize that. So in order to opt out of having T be sized, since all T as sized by default. Okay, that's good to know. Okay, so we have our new, that's fine. Now we have this into inner. Into inner unwraps the value. So what exactly does that mean? Does it just give me, does it consume the unsafe cell and like gives that to me? So let's go and play around with it and see if we can understand that a little bit more. So, checking into inner. So let's just create a new one, and we're gonna store like a, I mean, we can still store this location. So we're gonna do let wrapped location is going to be equal to a unsafe cell new location with x of 10, y of 20. Okay, so I have that. Now I want to get this back out. So let unwrapped location is going to be wrapped location dot into inner. Now that just gives me this location here, which is fine. So if I debug the unwrapped location, let's go ahead and comment all that out. We get you. Okay, so that's fine. Now, the unsafe cell I think is gone. I consumed it, I believe, with the into inner. So if I try to do anything else with it again, it's like if I try to get that pointer from it, so like just a equals our wrapped location dot get. If I try to do that, borrow the move. So we can't do this anymore. Can't do this since we consumed the wrapped location with the into inner. So consume the unsafe cell and turn a, let's see, we want to return what? Consume the unsafe cell and return a, return like the contents. So return the data that's stored inside. Okay. Then we have get. So this is going to be, so get a mutable pointer to the wrapped value. So get a mutable pointer, t, to the stored value. This pointer can be cast to any kind, but would need an unsafe block to use it. And then we have this get mute. So interestingly enough, this is a pointer t for get, and then we have this get mute, which just gets a mutable reference. Yeah, no, I have noticed that at Blarg, and I do think that that's really nice. It's like the into always consumes, which is nice. Also, hello. Okay, so then we have this get mute. So in this case, we're not getting a pointer to t or a star t. We're instead getting a mutable reference. So safely get a mutable reference to the value stored. Using it doesn't need an unsafe block, but we can't do like the multiple at a time that we can do with a pointer. Oh, it's really annoying to go back and look at your old code written before you had noticed those naming patterns. Like, so I've noticed the naming patterns, but I don't always remember it. Like, I sometimes still sort of like forget which ones are which, and that does sort of cause those issues. So it's one of those things where like I'm aware of it when I like think about it, but I need to like still be, it hasn't internalized for me yet. Which is most likely because I haven't like used it in a real scenario. That's really what like it is all about. Is just using it, practice, getting into it. We'll get there. Let's see, using it in a block, but you can't do the fun stuff with unsafe, like with get. Okay. Now there's this raw get here, but it's a nightly only, so we're not gonna add that in because we're not doing like nightly yet. But it's get a mutable pointer to the wrapped value. So how is this different? So this is a mutable pointer to t. This is a mutable pointer to t. But, ooh, look at this. Raw get, it doesn't take self. Oh, so this would be like a static method, essentially, on unsafe cell. The difference to get is that this function accepts a raw pointer, which is useful to avoid the creation of temporary references. The result can be cast to a pointer of any kind, so it's the same there. So like if I have an unsafe, I can do unsafe cell and then hand it any pointer. And then it will sort of like get me what I need. All right. As we can see here, this unsafe cell, raw get this M as a pointer. All right, so we have, you think there's a naming convention page in the official API guidelines? I don't think I've actually gone and read that. That would make sense. So then we have trait implementations. So what traits does this have? We have debug. Like obviously debug, it just, so we can display this as, you know, debugging. So like can display using the debug macro or question mark when printing. Okay, so default. Interesting. Creates an unsafe cell with a default value for t. Oh no. Epic Blarg, what happened? Hold on, give me 1 second. Nightbot could do. It was a link. Can I do something here? Hold on. Stop. Give me write access. Can I do like VIP? Oh, I can't create you as a VIP. I have to do this through this thing here. Oh, come on. Restore you. Where's the VIP section? The not sections. Community? Oh, roles. There it is. Epic. New. Epic. Larg. Oh man, there's so many. Okay, 2. I think that's you. You've been around long enough. I just gave you VIP. Try posting again. I think I have it set up where you're allowed to now. Nightbot will allow you to post links now. I think. There we go. Okay. And I should add that in to the whitelist too, which makes, yeah. Okay. So also you don't do that. I need to go find that chat. Oh, and of course didn't add you. I'll do that. I'll have to do that later. I'll probably forget. All right, back to main. Okay, so that's the Rustlang GitHub.io API guidelines naming. Let's go take a look at that. So it's in so rustlang.github.io, rust-lang.github.io/API guidelines. Naming. There we go. Darth Millennial, hello, good morning. Happy Sunday indeed. And so we should see things like into, okay, so like as to into, these type of conversions are, so like as is borrowed to, so borrowed goes to borrowed, borrowed goes to owned for non-copy types. Okay, so this is really interesting, sort of like to see this here. So I like this. Thank you for that. Now default, what the heck value is it going to give us for default? It's going to run default on that T. That's what it is. It's going to run default for the T. So if I give a default in here, then I should be able to do like let wrapped default location is going to be equal to an unsafe cell. Now I have to give it like what this type is going to be. So you're a location default, like that. And then we should be able to like sort of see what this is, and it should be zeros. And also we learned that we can debug this. So I should be able to do debug of the wrapped default location and see what we got in here. Which, well, okay, so fine. It's just that unsafe cell. So it's not super, super great. Let's go ahead and do into inner to grab that information out. And we should see it's then 0. So it ran default on the type that we're storing into it. Tough Rust weekend this weekend. You're trying to implement validator in Tide server. So many errors. I have run into those type of like errors when like, oh, let me just make one little change. 500 errors. Oh, okay, fun times. Also, apparently I have a poll that I need to do. That's gonna be fun. So let's back over here. Okay, so we have default. So create a new, I guess like construct. So construct a new unsafe cell. And call the static. I know it's not really called like static, but like in my mind, I still sort of like see those as like static methods on like classes almost. Static method default on the type for the value to be stored. So obviously, if our location here doesn't implement default, so if I remove you, this is going to fail. And it's going to yell at us saying, hey, everything we're doing has to implement default, otherwise like it doesn't know what this is going to be. All right, continuing on. Okay, so we have a from. Okay, so we can do like the from conversion for everything. So from T for unsafe cell. So performs a conversion. Now, can I see? Oh, there's this coast unsized. Now I think we did a from already. So if there is a from, if from is implemented for this type for something else, then we can do a from. But like I can't do from like location. Exploring, we're doing a deep dive. Actually, so something my wife bought me a long time ago, and I just completely forgot about it. But I told her like, oh yeah, I might do some like deep dive and spelunking into like, you know, code bases and other types of things. And she's saying, you know what we should get? An explorer's hat. And like I found it the other day and I put it next to my desk and I just forget about it every time. But she gave me this to like, hey, look, I'm exploring. And I just never really thought about it. Like until even now when you mentioned it. But yeah, it's exploring. It's an explorer's hat. I don't know if it's something that here's a question. Should I wear this whenever we're doing exploring and spelunking? I'm fine with it. I think it's pretty cool. Oh, definitely. Okay, we're doing it then. Nice. Thank you, Chantilly. Yeah, it's a nice hat. The only negative to it is it's loose enough on my head that I can't take it out when it's really windy. So it's really only going to be for the stream. It gets pretty windy here in Colorado. So what was I doing? We were going to do, from. So I can't do like a from for location. So let's try this again. So like, let's I kind of want to like break all this out now into like different functions so I don't have to like have all this here. Let's do this first. So what was this first one? This was just playing with creating a custom ref cell. So function using custom ref cell. I'm gonna take all of you. That's really all of this stuff. And you go in here, which means I can now do this. But I guess it's not really all of this stuff, right? Because we've got you. Okay, so now I have this unsafe block. This is, the console location. So, still part of this. Let's do another one. So function, sort of like multiple pointers, multiple mutable pointers. So that is where this comes in. Now you need this replication, which means you need this. So I'm going to grab you out of here, put you in here. And I guess you two can go up there. Okay. And I'm going to now call this from main. Now, I think I need to call the function as unsafe too, right? So if I do using custom ref cell, just like that, and then multiple mutable pointers. No, they don't, because this unsafe, this isn't unsafe. I guess I could call this unsafe in here, but because the unsafe is like fully encased inside this function, we're fine there. Okay, we have this into inner. Oh, so like then we're grabbing into inner. So function into inner. Grabbing this information and sort of debugging that. Let's cut you out and throw you in here. Okay, now I can do into inner there. And finally, we got default. Which is all of you. I think this is going to be a nicer way to sort of like organize this code. So if I want to turn off some of these like logs that are coming out, I'll just turn off these. All right, so let's continue on. Let's see. Has anyone got any experience Rust coding on a Mac M1? So I don't have a Mac M1. I've heard that some people have had pretty good experiences with it. At least now, I think the latest versions of Rust fully support it. So I think it's good now. For graphics programming and like the other libraries that you might want to call from Rust, I don't know how nice that is yet. That being said, like when the M2 comes out, I sort of feel that things will probably be good at that point in time. And I'll probably be ready to like switch over to that if I wanted to. I haven't decided yet. Most likely I'll probably get an M2. I just sort of like gotta think about it. Okay, so what was it that we were gonna look at? We were gonna look at from. So we want to play with from. So function. Let's do a from location. Right, so it's interesting. I've got this computer is a desktop running Windows. So yeah, this is just a Windows computer. I use it for like gaming. I use it for like graphics programming, streaming. I guess like I have a Linux computer, but the disk drive failed, and so I need to like rebuild it and like refix that down, but it was also starting to get old and not really running that fast. I tried streaming with it, and it was like pretty horrifying experience, with Rust at least. It was just like taking too much of the CPU to like really work properly. I could run with it without streaming, so that works just fine. Now, for I have a work computer that is Mac. And that's been great for me. And as you can see, I'm using Codespaces, which is going into an Ubuntu essential image. I'm pretty sure it's Ubuntu. I haven't looked. And this has been like great. So essentially I'm on Windows, the equivalent SSH'd in through VS Code into a virtual machine. It's quite interesting. All right, so if I want to do a from location, so let's do from, see how does this work? It's from location into a unsafe cell, which does give me into capabilities. So I should be able to do, so far performance is pretty good. Like you can see my library that I was running with for like all my tests, they're all running pretty fast so far. Now, it's still a virtual machine, which means any graphics stuff I want to do on there is going to be a big no-go. Like I'm not going to do any graphics on that because, well, I've just got a headless SSH into it essentially. So that's another thing I'll have to like keep in mind. Also, I can open up ports and forward ports out, which is something I'm looking forward to if I do web-based stuff, which will be pretty cool. Because then I can share those with you without risking my IP address, which will be nice. All right, so from location. So if I wanted to do let's, and I think they have like sort of from a type into the unsafe cell. So I think it's it would be okay. So let my like wrapped location is equal to, I can either do the inner into, or I can do a from, right? So I can do a unsafe cell from like a location. So location x is 10.0. I think actually we just do default here. Now it's gonna yell at me. Oh, it just works. So then if I do a debug of our wrapped location, yeah, I guess it's able to figure that out pretty nicely, which means I can do a into too, doesn't it? Into inner. I wish I could do that as a run. Then that just works. So I just get that for free in here. Now, can I tell you that you're an unsafe cell? So you're going to be a type unsafe cell location inside. And then I want to do location default into. And this should also work. How well does cargo docs open work on CodeSpace? I don't think this is going to work at all, like in any way whatsoever. But let's try it. So if I do cargo docs open, it's not going to be able to find. It's not going to be able to find a document server. Like it's not going to be able to find a browser because I don't have one open. No. Yeah, so it's trying to open this. Now I don't have any ports forwarded, so I can't go there. That being said, if I look at this, okay, so it's workspaces, exploring Rust and target docs, exploring Rust in here. Is it HTTP? Is that the crate? Or is it HTML? No, no. What's the one? What's like the crate where I can just start up a server and it just serves localhost? I don't remember what it is. I need to find like a web server. Like I just want like a really, really basic one that just serves up localhost, but I don't remember what it's called. I remember it's something really simple. It's probably not been updated in a long time because once you like build it, you don't need to do anything else. Okay, there's this mini serve for when you want to serve some files over HTTP right now. Take a look at this. Self-contained cross-product. Okay, so just grab some through binary, serve some files. Okay, so serve a directory. That's what I want to do. So let's go ahead and install miniserve. So I'm not going to install it on my computer. I'm going to install it into this code space here. So we're going to do a cargo install miniserve. Okay. No, I was going to say nice and fast, but this is going to take just a hot minute. I will be right back. So obviously, still a little bit. It's like it's not the fastest system, but you can see right now this is like the smallest possible code space we got, and it's decently fast for this. You know about Rest? Always did Python's HTTP simple server. I've also forgotten the name of that one too. I just like I use them so infrequently that I don't really remember these. I should probably write them down. Pretty good for 346 packages. Yeah, I mean that's kind of like how I feel about this. Is CodeSpace is like they're not skimping on this. They're giving me a pretty decent system here. And we're almost there, but we're close. Oh, it has to. It's Actix Web. Well, Actix Web is a pretty slow compile too. At least it was back when we did it. Like I don't. Were any of you here when I did the Actix Web sort of Explorer? The starting soon screen that I'm showing right now, that is served through an Actix Web server, but I don't remember what version it was. But that was like a really long compilation. Okay, so this is done. So we can now do a mini serve. So I've already forgotten what the so I think it was in target. So it was, we do a mini serve, target, doc. I guess like there's settings. Where's like the index? Just anyhow. There's source. Is this just everything? Should I just store this? Should I just serve this? Let's serve that. Okay, so notice here, now I get this application warning in port 8080. I can come over here to ports and see that I've got this like 127.0.0.0.1 open here. So let me go ahead and open that up. Here you are. This is, oh, okay. This is what I want. Okay. So I was close. I wanted explain REST standard library, and then that is it. So I'm gonna come back. Gonna turn off the server, paste a doc, explain REST, open that up, and that gives me a link that only I can see on localhost. I want to get a, no, that's the wrong one. Come on. Give me, make public. And then this gives me a new URL here, which then goes to actually GitHub. So we can now see, you have to be logged into GitHub to get it. Oh, wait, it's only to me. Oh no, it's public. So anybody can get theirs, but they have to be logged into GitHub to see it. And so at this point in time, I think that I can copy you and give this to all of you, and you could go and explore this if I so desired. And we can see from the URL that this is not served on my computer. It's served on oh, and it's none of this is working correctly. It's okay. Miniserve maybe not be great. So that's not the best, but there you go with that. So yeah, it's it'll be a thing. I'll have to like play around with it, find something else for this type of thing, but perhaps for serving the documentation, its mini server is not great, but like other things, when I create web servers, we can then do that with. I should probably hide that too, because I didn't check to see what like this information was going on in like our terminal. So I'm good with that. I'm gonna go ahead and turn off you. Yeah, you can't find stuff. Oh, I have to CD into that directory probably first for it to work properly. I think that's what that is. All right, so continuing back to this. So we have from location, just works with anything. It just is good for us. So allows us use so unsafe cell from or I guess like it would be t dot into to get an unsafe cell. Works with like pretty much everything. All right, continuing on. We have coerce unsize. I don't think I'm familiar with this one. Coerce unsized. Oh, wait. Oh, that's nightly only. Oh, well, that explains that. Nightly only. Could be interesting once once that becomes open up for us. Let's see, Intel option sized. So Intel that question mark sized. So the question mark is opting out of sized, so that the data stored can basically be anything. Sized or not. And sync, meaning that this must be inside. Oh, wait, is that not sync? Not sync. Okay. Not sync, meaning that this can be used inside of. This can be used inside of threads. So can be used in asynchronous programming. Okay, so there's the auto trade implementations, which I don't think we need to worry too much about this. So interestingly enough, I guess like it's send. So it implements send and unpin. Unpin was like one of those things where I'm like slowly starting to get more knowledge of, but not enough to like really dive into it yet. To do unpin for the, like almost everything gets unpinned from the standard library, which kind of makes it a little bit hard for us to use pin and like get into trouble with it, because if it auto unpins for us, then I can't actually force in like an error. So that'll be interesting. And then unwind safe is also interesting there. Okay, and our blanket implementations, I don't think we need to worry about any of this stuff. So like we get any, we get borrow mute, so we can do all the normal things. So interesting, like the borrow and a borrow mute, from what we learned from borrow, is that gives you the thing inside of it. So you can essentially borrow the unsafe cell and you get the T, which is the data inside of it, as opposed to the unsafe cell being borrowed itself, if that makes sense. And then all the other good stuff in here. Okay, so I think we're good to go here. Nope, didn't want to do that. Let us come back to here. Unsafe cell, we're done with you. Let's go take a look at read. Actually, before I do that, let's remove some of these problems we ran into. Also, wait, I need to, there you go, okay. Pull whatever changes there were that I somehow created elsewhere. Let's fix all these problems. So, don't care about you. Right, the hasher stuff, I think we still need to learn a little bit more than that before we start using, like, look into those. Okay, so our custom ref cell, I thought, oh, I need to turn these back on. Function default, let's go ahead and call that up here. And there we go, no more warnings or errors, so we can then, let's see, what was this? This is unsafe cell. Okay, so I believe this next one is read, right? Yeah, pointer read. Okay, so standard pointer read, it's a function. Reads the value from source without moving it. This leaves the memory in source unchanged. So reads the value from source being what's passed into it. With this, okay. With a star pointer, so a pointer T, without moving it. And it gives me this T back. It's got to be unsafe. It leaves the memory and source unchanged. Okay, so source must be valid for reads, source must be properly aligned. So we've got to use an unsafe cell to get that pointer, I think. Unless there's like other ways to get that. But let's create one. So let's do what does the const represent in this context? It's a const pointer to a place in memory. Like basically think of it as a immutable pointer to a location in memory, which if you like, the immutable is maybe a little bit tricky there because the pointer is immutable, but the memory that is pointing to is mutable. Like I can change that if I really wanted to, using some like trickery. But in this case, I'm curious like what I can do with read, because it looks to me like it's going to be giving me, without moving it, and it's going to leave the memory unchanged. So let's sort of like recreate what we did in Unsafe Cell here. So let like our unsafe cell. So this is gonna be our wrapper, I guess. It's gonna be equal to an unsafe cell. We'll just do a default of like I don't know, an I32. I need you to go over here. Like that. Okay, so now my wrapper is an unsafe cell that has an I32 in it, which is going to be a 0. So now I should be able to call this read on it. So let's, maybe this is unwrapped equals read. So I think it's pointer. So standard pointer read. Now I need to get this like const thing. So let's do let our pointer, it's going to be equal to this wrapper dot get. Now this is that, like it says this mute here, but I can really also say that this is star const and I32. And I think that's going to be the exact same thing here. So I'm going to say pointer to you. Now you are unsafe, so you need to be wrapped in an unsafe here. So I do that. And if I return you, I get this I32 out. And so let's debug the unwrapped. You should be just 0. And there we go. We got it. It's 0. Now, if I wanted to try to like do something with it, I guess like it's just a way for me to take the pointer and read out of it without having to do any crazy like dereferencing. I guess that's kind of what we're getting at here. Now, I32s do implement clone and copy. So I'm curious whether or not read requires that. Let's create our own type here really quickly. So let's do a struct, sort of like a wrapper. It's like number wrapper, and you're gonna hold an I32 inside of you like that. So I want you to be, we can implement, we're gonna derive a debug and default here. So you're gonna be a number wrapper. Okay. Not going to say exactly what you are. So now we have this mutable, this pointer to number wrapper. And if I do that, I still sort of like get access to you. I'm guessing that the pointer is consumed at this point in time. It's like, can I do this again? So unwrapped again, and let's try debugging both of them. And I can't. Now it's like too immutable, but I don't implement clone or copy. So it's not doing a copy. Pointers are copies, they never get consumed. Ah, okay. So the pointer is being copied over. So that's what it is. So it's the same thing happening here. So now I'm getting this number wrapper, but it's the same number wrapper. Let's try, if I derive equal, not partial equal, but just equal, I should also be able to do assert equal unwrapped and unwrapped again. And you need to be like exactly the same thing. Oh, can I not do this? Oh, right, I have to do this with partial equal, which then kind of defeats the purpose. So I can't do that. Can't derive. So I can't do that without partial equal. How can I make sure they actually are the same thing? Like I'm certain that they're the same thing. But like it feels strange that like I have you, right? Now, is there a read mute too? Unwrapped and unwrapped games are different instances. Yeah, and that's the one thing is like I want to verify if they really are different instances or not, because I want to say that they shouldn't be, right? Because here we have this unsafe cell and I get the pointer to that and then I grab you out. Now you're not cloning or copying. It can't do that because number wrapper doesn't implement clone or copy. Oh, Rust Analyzer is not happy. So we need to go, I don't know how to like verify that this is like the same instance or not yet. Okay, it could be done for like mem swap. Oh, right. I keep on forgetting we can do the colon P. Oh man. Yes, we can do that. So instead of debug, let's change this into a print line. And we're gonna say, I want, are you equal to this? We're gonna do colon P for the pointer to memory. I keep on forgetting like that I can do this kind of like tricksy cool stuff. So if I run you, the trait pointer is not implemented for number wrapper. Okay, so I need to implement pointer for this. Can I derive that? Oh, it has to be a reference to it. Okay, got it. Ooh, if it's gonna be a reference, they might be two different references. They might not be the same. Let's try it. 7FF, E41, E8. Oh no, they're not the same. Look at this. Okay, 670, 674. So they're not the same in memory, but I think it's this that's making them not the same on memory. I think I may be measuring the wrong. It's maybe measuring the wrong thing. which is okay. Let's continue looking through this. Maybe we'll understand this more. So we do a pointer read of A, which is oh, look at this. Create a bitwise copy of the value at A. So it is a new thing. So it's how you can, okay. Exiting this point, either by calling a function panx would cause the value in temp to be dropped. Well, yes. While the same value is still referenced by A, this could trigger undefined behavior if T is not copy. So T is not copy here. Now, interesting. Okay, so unsafe. I get this out. This could cause undefined behavior. That's interesting. If you want to know the location of the reference, oh, okay, so those, okay, so it is different things. And now take a look at this. This is a bitwise copy of the value. So I think, come down here. Okay, so read returns a bitwise copy of T regardless of whether or not T is copy. If T is not copy, using both the return value and the value at source can violate memory safety. So T in our case is not copy. Using both the return value and the value at source, at pointer source, can violate memory safety. Note that assigning to pointer source counts as a use because it will attempt to drop the value at pointer source. Interesting. Okay. So write can be used. So we're getting a bitwise copy at this point in time. So unwrapped is, so I guess number wrapper. So that's why it works. There are bitwise copies of it regardless of if it implements clone or not. Write can be used to overwrite data without causing it to be dropped. So read will cause a drop. So we get a pointer to this S, a reference to S. So S2 now points to the same underlying memory as S. But it's a bitwise copy, meaning that it's not like this. Okay, so wait, it points to the same memory as S. So then I'm incorrect in what I did, in what I wrote. Assigning to S2 causes the original value to be dropped. Beyond this point, S is no longer used as the underlying memory has been freed. Okay. So like, I take S2, it drops S2, but that also causes S to drop at the same time. But I don't think I can actually do that. I don't think it will let me, but let's try it. Let's create a function to like, to store this entire into. So this is just like reading from unsafe cell. All right, let's try doing this next one, which is going to be really unsafe. I guess like dropping, like this is dropping dropping one of the copies, like dropping a copy. All right, so let's do sort of like we'll use the number wrapper again here. So we'll do let our, so like number is going to be equal to our number wrapper with like 10 inside. Okay, now we need to do unsafe, I think, but let's see, let's make it, oh yeah, we have to use unsafe because read is unsafe. We're gonna do an unsafe block here. So we're gonna do same number. It's equal to standard pointer read, and it's gonna be a reference to number. So that gives me a same pointer to number. So I think this is incorrect there. So we have our same number. If I replace same number, so same number, don't think I can do an equals here without making this mutable. Is equal to like number wrapper 15. So if I do that, you need to be mutable, right? Value assigned to same number is never read. And you assign it on by default. Maybe it's being overridden before it's read. Okay, so let's make this mute here. So I think this is not exactly the same example because I think it was a let that they were doing, which dropped same number and recreated it with the same name. Now, if I do this and we come back down here, I want to do a debug of number because it should now be 15. No, it's 10. So it is not the same. Now if I do, because number wrapper is not a smart pointer, but string is. Oh, because it's a smart pointer. Okay, let's not do smart number wrapper. We'll do string. So string from hello. We'll do that. String, same string. Okay, so we get that. You're gonna be a brand new string again. But you're still okay with this. Look at that. Okay. So our string is this. We see that out here, but a double free detected in Tcache 2. So double free detected. So it dropped. We overwrote here. Interesting. So I debug this string. Guess I don't really want to debug. Do you? I just want to do like a print line. What do you have inside of you? I guess like it's this thing now. Oh, okay. It won't let me see. You have a double free detected, And so here's variable same string assigned to but never used. Okay. That's fine. Same string is never read. Function is never used. Okay. Understood. Okay. Now, if I do this as a let, I think now it's going to say string is dropped. You don't need to be mutable anymore. If I just shadow you twice, I drop the string, because when this drops, it drops everything that points to it at the same time. And that's why we see a double free, because it drops this, which also drops this at the same time. So that's really interesting. Look at that. This is what was printed out. So it lets me do it. It's not necessarily the best behavior. Zilby, hi. Come here. Come here. Kitty. I don't think he's seen me wear this hat before, so he might be slightly freaked out by that. Oh, he wants to go play in a box that I have over on the side. Yeah, or a bag. All right. Very unsure of the hat. Very unsure of the hat. Okay, so this is interesting. So is this memory location that it shouldn't be detecting? Now, same string, it can't get access to this here. So that's really interesting. It's used out free, so it reads it's garbage data. It's interesting that it lets me do that, but it lets me do that because I'm the unsafe. So like I've done something really bad here. So to make this safer again, I need to make sure I read this string here, which means we're going to do something like let other equals to you, and we're going to return that. And now I can just like do this as the other. And then this will be happier, but like we're not doing the same drop. It's much nicer and like better. So double free detected. Yeah, I still have double free detected. But I'm just not doing the same bad thing here. So that's actually really interesting. Now, write can be used to overwrite the data without causing it to be dropped. So that's actually really interesting. So maybe we could take a look at write next. But so basically this is like get a pointer to a location in data to that can be read. If we write to that pointer, we will cause a double free, which will, I guess like drop, which will have potentially unexpected results without crashing the app. So like if we want to know how to read garbage data from memory, this is a way to do it. Now, can I make this like safer? So we have our string in here. What if I do my sort of like my other here as unsafe, and then we're going to do a standard pointer read a reference to string like that. Now I get this other like that, and then I can read this other here. And I can also do a print line. Actually, let's do like this. So we read both of them here. We get hello, hello, but we're still seeing a double free at this point. We're still seeing a double free. Now, do I have to do a drop myself? Do I have to drop other manually first, and then string can be dropped safely at the end? No. Okay, so double free is still happening even if I manually drop you there. Because if I drop you, it drops the other at the same time. And I don't think I can drop multiple things at the same time. Can I? So will read always cause a double free? String another contains the same pointer. Yes, that's a good point. So it will cause right to pointer pressing app. So like so get a pointer to, if we write to that pointer, heck, if we do anything with that pointer, if we drop that pointer. So if we write to the pointer or the pointer drops for any reason, we will cause a double free, which will have potentially unexpected results without crashing the app. So I think that's the interesting thing. And I can't drop it myself because I can't drop them fast enough, right? So when would I want to use this? Or is it always going to be like internal, other people do it for me? So we have this. So get that. There's manually drop. Is manually drop a oh, it's a struct. Really? So wait, can I do manually drop? So how do I use it? A wrapper to inhibit compiler from automatically calling T's destructor. Okay. This wrapper is 0 cost. You don't have any data. Wait. You have data, but you're not showing me what that is. Okay, so there's new. And it has the value. Okay, write. Oh, write the value to be manually dropped. Okay. So manually dropped, new. If I throw the string in here, or I throw the other. So what are you? You're this manually dropped string. Now I want to drop other. And can I still read the S? So can I still like, let's do a debug of S. It drops it, so I get garbage data still, but I'm no longer, I get my hello hello from this. I drop the other. I no longer get a double free detected because I only free one of them, but I still can get garbage value out of this. So like, this is, I would need to manually wrap like both these in a manually drop if I want to like not have it drop. So that's really interesting here. Is this is how I can get garbage data and sort of like read from the read from memory. This seems wildly unsafe. It kind of does, doesn't it? This seems like something that like you could implement like Heartbleed type stuff in. Where it's like, hey, maybe if I have like a big enough thing, I can then get just sort of like something in memory that like actually is something. Now, there is a reason why I need unsafe to do this. So if somebody is like looking through my code base and sees this unsafe here, it's like, it's an alert to be hyper alert that I'm doing something stupid. Now maybe I'm not doing something stupid. Maybe I really need to do this for whatever I'm doing. But then they see like me doing this afterwards, and like you're like the sort of like the warning bell should be going off as what is happening? And it's like, oh, what are you doing? Why are you doing this? Stop it. So technically works. But as you said, wildly unsafe. But it's still kind of cool to see that you could do this if you wanted to. So let's actually go into manually. Let's add manually drop to the queue. Read is done. Okay, so let's do write, and then I'll probably call it for the day because I'm starting to get hungry and I need to go up and grab some lunch. So we'll do write, and then I'll let you know what my update schedule is going to be, and then I'll wrap it up. So write. This is going to be the pointer write, which is this function for it. So let's go ahead and give ourselves overwrites a memory location with the given value without reading or dropping the old value. Write does not drop the contents of DST. This is safe. Oh, DST, destination. This is safe. but it could leak allocations or resources, so care should be taken not to overwrite an object that should be dropped. Additionally, it does not drop source. Semantically, source is moved into the location pointed to by destination, but it's not dropped. Interesting. This is, so it is unsafe here. This is appropriately for initializing uninitialized memory or overwriting memory that has previously been read from. So let's take a look at what we can do with this. So let's create like a string again. So we'll do like let hello equals string from hello. Now we want to read from this. So let's just do a debug. We'll give it like a reference to hello. Okay, pretty simple. We run this and we get exactly what we sort of expect to get from that. Now I want to write. So I want to, we're gonna do a standard pointer write. So our destination is a new thing. So I need to have let mute world So let's put world in here and hello in here. Now you, oh right, we need to put this in unsafe. Now you, uninitialized value. Okay, so we need to give you, now you know that you're a string, but let's just say that you're going to be a string from world. Now I'm overwriting the world with the from. Rust Analyzer is upset again. And let's do another debug of a reference to world. Okay, so now what? Expected a raw pointer. Okay, so can I do this or do I have to do like the star const as? I think I have to do like star const. Oh, what was it? Like as? Or world as? Expected a raw pointer. A pointer mute. Okay, so I do you. Non-primitive cast. Consider borrowing. Okay, so I can't do that. Let's do a pointer at world. Expected a raw pointer found type stir. Okay, so if I dereferenced it, I don't want that. How would I get you as a raw pointer? Okay, we could try that. So let's do world as. Let's try that again. No. Casting a string as a mutable pointer is invalid. Okay, so I can't do that. Okay. Can I do an into for this? Do world.into? No, not that. Nope, it can't figure out how to do that because, okay, convert from string is not satisfied. Okay. Oh yeah, let's try that one too. So we'll do mute world as mute that. There we go. Okay, that worked. That worked. So we got a pointer. Now I could also call this like a pointer here. It's like let better pointer equals, so mute world as that. So now we have this in here, and we're gonna just throw you in here. Now I want to debug world. Oh, the as is unnecessary. Let's try it. Ah, you're correct. Okay, so actually, in that case, I can do mute world. There we go. Okay, why do I have pattern? I don't need you. Go away. Okay, so if I debug world here, so we show you, they both have hello in it, but this hello should not be dropped, meaning I should be able to debug this again with a hello here. Borrow move value. Oh, it was. Okay, so you were line 6. So you were moved here. I thought it didn't drop it, but I guess it moves it and not drops it. Oh, semantically, source is moved into the location pointed to by dest. So it's not dropped, but it is moved. So if I wanted to not move it, I don't know if I can like do a reference to that, because it needs like an actual thing, doesn't it? I could do like a dereference, but then that's not like, it needs to be the same type. So I can clone it, but then that doesn't really do the same thing here. So we sort of like lose that entire thing. Now, if I do like a hello, so I debug hello, and let's do the opposite. Let's do hello happens here, and world happens here. You're gonna need to be mutable. You don't need to be mutable. Then you're moved, so I can't use you, but we can take a look at hello again. So we're going to see it be hello, and then we're going to see it be world. So we're able to write to that specific point in memory. World is now unusable because it's moved. So we can no longer use world because it's moved. Hello is now world, and here it is hello. So we sort of like write into that place in memory, which is interesting. So right into a pointer. I guess it's a mutable pointer. So pointer from a borrowed, I guess like an owned from a value, which it takes ownership of. And so that's the example of what we got for it. So it's interesting. So it's quite like, it's very interesting of like what we can do with this, what this really means to us. Now again, like read and write, I don't really know when I would do this, like when I would use this. Maybe sometime like we'll Maybe someday I'll figure out something like I'll run into a problem where I absolutely need to do this. I feel like I stay high, like most of my programming and the projects I'm doing are high enough level that I don't run into things where I need to do this type of memory manipulation. But it's interesting to have it as an option, to know that it exists is like, I guess it's interesting. So, this code also leaks memory. Where are we leaking memory? So I can't use world anymore. And debugging hello, I guess 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ah, okay. So hold on. Let's do a W there. So I'm putting in a smaller thing than this thing. So now, am I gonna get garbage data? No, I still don't get garbage data. I suppose I don't have to be a string, right? I can put maybe something else in there. The string from line 2 is not dropped. Correct. I'm reading it here again. So I'm reading it in 2 places. Oh, you're talking about this string, like the original hello is not dropped. Oh, well, hold on. It's gone though. So overwrite the memory location with the given value without reading or dropping the old value. Right, does not drop the contents of destination. This is safe, but it could leak allocations resources. Be careful to take. This is appropriate for initializing or overwriting memory that has previously been read from. So we can do read with this. Okay, so this is just like function overwriting memory. Okay, so what if we do another one here? So let's try using read. Because I think that's where this gets a little bit more interesting. So let's say we have our hello and our world again. So we're going to do let hello equals string from hello. Let world equals string from world. Okay, so I have both of those. Now I can do a read. I can do a read to hello. So we're going to do an unsafe block here. And then we can do a let read hello equals standard pointer read. This is going to be a reference to hello. So now I have the hellos in memory, which means we're going to have a double free error. Guess it's not really an error, it's double free warning. And I can like debug this, I can do whatever I want to it, but I can also write to it. So let's do like a debug of read hello. Let's not actually drop it at this point. Let's not take ownership of it. Okay, so I do it on there. Let's also debug a reference to hello here and a reference to world here. We're doing a debug reference to read hello. Now I want to write. So we're going to write a standard pointer right. My destination is going to be this mutable hello, and my source is going to be a new string from new hello. We're going to do that. I guess we just use world, and it's dropped now. So world is now owned by this write function. So I can't use world anymore. This function ends, and now I want to do another debug of a reference to hello. I can no longer do one to world. You need to be mutable here. So using read. No double free. So we've fixed our double free error because we've now overwritten that word. So we start with hello is hello, world is world. Our read hello is hello because it's the same like sort of pointer to the same place in memory. Okay, understood. And then hello becomes world. So we put world in the place in hello in memory. Read hello gets dropped, that's gone forever, and hello is still readable, and like we don't have garbage anything. So that is something really interesting. So okay, so if we use read, so okay, if we use read to get a pointer to a place in memory, and then overwrite that pointer, we can still use the originating value if we write to it. Otherwise, we would get a double free error. Okay, that's what we can do for it. And that's what write is really going to let us do here, is use read in a way that's slightly safer for us doing this stuff later. So that's interesting. I wonder if I can do like weird read stuff like can I do something really insane? Like self read. So I create this hello. I don't care about the world. So we debug hello. We have our unsafe block. So I do read hello to give me the pointer to hello. There we go with that. Now I want the read hello. We debug that. Okay, I'm going to write into hello, but I've already got a read to that, so that's going to be interesting. And then I want this to be coming from read hello. Then read hello gets owned. See what happens. It works. I can do that. So I can get a pointer to it. Now, I think that I can, at this point in time, change read hello too. So I think I can say, let's make you mutable. I can do read hello dot push a character. So we can just push like S for hellos now. Then I'm gonna write this back in there and then debug hello. We should get hellos. Oh wait, you know what would be helpful? Actually calling this function to make sure that it actually does work. Now we get those hellos. So I get a pointer to it, I manipulate the pointer, and I save like the pointer stuff back into the originating variable. Totally fine. Again, like it doesn't feel like it's something that I can use for real, but maybe someday I'll run into this. It does seem pretty cool though. So we can also use write to store the pointer, or like it's not store the pointer, to like write the memory from the pointer received from read back into the originating value read from. I don't know, that seems like a weird way of saying like you can go back around. Maybe you can use read write to do buffer reuse optimization like you would do in C. No, that's a possibility. That is a possibility. I wonder how like the sizes work with this. Like if I don't use string, well, everything is going to be sized, isn't it? What's something that we don't know the size of? Like string, we don't know the size of it, but it's really like I'm storing a string, which is a pointer towards like the equivalent of like a vector in memory, in memory. So if that changes, that's fine. It's still going to be like just I'm pointing towards something else. It's not really helpful in this case. If I do like an array, can I do an array of different sizes? So let's do let like we'll have some numbers. It's like we'll do large. So let large equals an array of like 1, 2, 3, 4, 5. I know it's not really large, but bear with me. So I'm going to make you mutable. I don't need to debug you. This will be fine. Okay, so then let's do our unsafe block. And we're going to get our read. So I'm thinking I'm gonna try to put like a size things here, but it's gonna be a different size. And I wonder if it's gonna let me do that, or if it's gonna yell bloody murder at me. My guess is it's gonna yell bloody murder at me, but who knows? Maybe it won't. So like our read from like large, so our pointer essentially is now going to be a standard pointer read of a reference to large. Okay, so I've got that I32.5. I can't really change that, can I? Because they have to be the same signature. And this is our signature. So, because I can't like push into it, I can't really change this at all in any way. I can't like change the type from I32 to something else. Let's see. So I could do maybe, can I do pointer equals literally any other size? I don't think it's going to let me. Like, I don't think I can do like 1, 2, 1, 2. it has to be the same number of things. Now I can do let and overwrite here. So now you're an I32 with 2. And so now I want to, you've dropped though. So can I write? We're gonna do a mutable large, and our source is gonna be this pointer. Yeah, it's gonna need to be that 5 size. This is gonna not work. You need to be the same signature as this. That's how it works. So like this fails. So dest and source must be the same type / size. Or I guess like have the same signature. So it must be the same type. That's really what it is. Must be the same type. So that's interesting. That's good to know and sort of like good to be aware of. Okay. And I think there it is that. I'm going to go ahead and remove that from our queue. There's transmute function that allows you to convert whatever to whatever, but that's extremely unsafe. That sounds fun. Do I have transmute? I do. Probably mem transmute. We'll add that into our queue, and we'll take a look at that. We'll take a look at that in the future. All right, so go ahead and close you up. In here, this is right, and I can now put all of these up here. Cool. So. I don't yet like, I guess like the last thing is we'll do a marker for this one. Cause I'm going to create like this as a quick little side video also on the channel. So, actually, you know what, before I even do that, I can do that. If I go far enough away, there we go. That looks decently okay. I'll take off my exploration hat. Hey everyone, Brooks here with a really quick channel update. So things are going a little bit crazy at my day job right now. Unfortunately, our team size has changed. Also, like just schooling time has changed for like the various team members. So I'm gonna be changing our schedule time. So previously my work sort of started around 9:30, 9:45. So I was able to do my streaming from like 8 until like 9:15 to 9:30, and then just sort of go off to work from there. Unfortunately, I can't do it anymore because our new stand-up time is going to be 8 a.m. And I can't get up early enough and get enough sleep to like function properly to be able to do a stream in the morning before that starts. So I don't know how long this is going to take. It's going to be, a little while before things settle down and I can maybe change the team schedule again. So until then, I know, ouch. The plan is that I'll be just like, doing my normal thing, no stream in the mornings on weekdays. And then I'll be getting off, at the normal time. I'll probably like grab some dinner, and I'm not gonna put it on a schedule yet because I'm gonna see if I can do an after work stream on some of these days. So if you're following me and you have notifications on and you're going to be like at bed or that time, I highly recommend that you probably turn those off because I'll be going online on some days just after work, which might be midnight for you. Otherwise, if you do want to be notified when I go on live, because I will tweet out also, then I would love if you followed and like sort of found me there. My plan is to be doing anti-burnout stuff, so I'll still be doing some like, diving deep into the REST library because I do find that a lot of fun, have a lot of meaning for me. But then I'm also probably going to be doing some like, light gameplay also. So like if I do like a 2-hour stream, it might be do something like an hour of like Rust and then an hour of gaming, or so on. I'll sort of like figure something out like that. I know it's gonna be rough. And that's the thing is like, it's gonna be more anti-burnout type stuff. So if I only can like game or like I only do like, fun little projects, that's what we'll do. So I'm sorry for everybody who has been used to me streaming at like a more friendly time for you over in like, the European time zones. I unfortunately am gonna have to change that up. Now Sundays, I'm gonna keep exactly the same. So we're going to still stream 9 a.m., maybe a little bit earlier Mountain Time, and then go through at least 12 p.m. Like right now, it's 12:35 for me, and I'm just sort of wrapping up now. So that way, I can still at least one day a week have a nice early stream. But that's pretty much what I'm going to have to be doing for a while. Now, I'm going to be archiving streams to YouTube, so if you want to like catch up there, I would love to like see comments in those videos. And then also I do have a Discord, and if you want to sort of like catch like what those videos are or just chat and hang out and to see when I'm going to be going live, you can catch up with me there as well. Anyways, thank you so much everybody for watching so far, and I look forward to seeing you online, live or not, in the future. Thanks. Bye. All right. Yeah, I know. I'm sorry, everybody. I wish it would be different, but right now the stream has to play second fiddle to the my team at my day job. It also helps that the day job pays a lot more than the stream does right now. So like, all you need is just to match my salary, and then in bits, and then I can quit that job. Which no, I don't try that. That it's gonna be a while before I get there, but I'm hoping that one day maybe I'll be able to create some like courses that actually I can sell for a profit. One day. All right, everybody. Coworker, hello. I am gonna go grab some lunch, sort of like hang around, see what I can do. Like I might buy an arm or something so I can get a second monitor going up here. I'm still like getting used to like a single display. Hopefully it was okay today. I also need to buy a UPS so we don't have any more power outages because that sucked. As I mentioned, I don't know when the next stream is going to be. I'm not going to full schedule it, but it can't be before 6:30 p.m. tomorrow Mountain Time. So everyone, have a great rest of your day. I'll see you next time, whenever that is. And bye.